Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to talk about Algebra 2, Chapter 5 review. This is the second half of the review from the Big Ideas book. These questions show up, but not exactly the same. This is a homework assignment that a student gave me to help them out with. So we're looking at this particular section is actually, if I'm not mistaken, exponential function, sorry, rational exponents and radical functions. So we're going to go ahead and do some changes to these exponential rational exponents and radical functions. Okay, so I'm assuming the instructions for this is just solve. So we're going to go ahead right away and just start solving. Our goal is always to get x on its own. So I'm going to go ahead and add 9 to both sides. I get square root x equals 11. And then in order to get rid of the square root, I'm just going to square both sides. So I'm going to end up with x equals 121. Final answer. Same business here. Since the radical x is already on its own, I'm going to go ahead and square this and square this. Now, one thing I want to make sure that you're doing is when you're squaring this in particular, you're not just putting x squared minus 36. You're actually going x minus 6, x minus 6, multiplying each other. So in this particular case, I'm going to FOIL. I'm going to end up with x squared minus 6x minus another 6x plus 36. I can combine like terms, so I'm going to end up with x equals x squared minus 12x plus 36. I'm going to subtract x from both sides. X squared minus 13x plus 36 equals 0. In this case, I know that I can factor, and my factors of 36 are 1 and 36, 2 and 18, 3 and 12. So far, nothing. And then 4 and 9 is actually the factors that we're looking for, because 4 plus 9 ends up with 13. And because I want negative 13, I'm going to go negative, and negative. I love that I wrote 9 instead of 0 because I knew, my brain knew ahead of time that it would be 9 in one of the parentheses. Okay. Then I know I'm going to go ahead and I'm going to say x is equal to 4 and x is equal to 9. Now, one of the things that you want to do is you want to double check to make sure your answers are correct. If I put 9 in place of this x, I'm going to end up with 3 on the left-hand side and 3 on the right-hand side because 9 minus 6 is 3. If I put 4 in here, I'm going to end up with 2 on the left-hand side and negative 2 on the right-hand side. So I actually need to reject the answer 4 because 4 will not make the equation true. And x equals 9 is the only possible answer. So sometimes you will have to go in to check to make sure that your answers work. Again, same business. I'm going to go ahead. I'm going to add. I now have the cube root of 3x equals 3. Instead of having the cube root, I'm going to cube it on both sides. So I'm going to end up with 3x equals 27. Divide both sides by 3, x equals 9. Again, same business, not anything crazy. We're going to do 9 times 3 is 27. Cube root of 27 is 3. 3 minus 6 is negative 3. We're good. In this particular case, we kind of have x on its own, kind of not. There's a lot going on. But anytime I see an exponent, I want to eliminate that exponent so that I can make my life easier. So I'm going to go ahead and I'm going to square this side and square this side. Now, in this case, it doesn't make sense for me to do 3x and 3x, one on each side. Instead, I'm just going to take this squared and distribute. Because I'm multiplying the 3 and the x, not adding. If I was adding, then I'd have to do exactly what I did in problem 2, kind of like this. Okay, so I've got x plus 10 here equals 9x squared. I'm going to move everything over to the same side. So I'm going to have 9x squared minus x plus 10 equals 0. And then I'm going to go in and straight factor. So I know my factors of 9x squared are 9 and 1. I'm going to go 9x and x. My factors, oh, whoops, hold on a second. I could have other possible options. So hold on. So 9 is 1 times 9 and 3 times 3. 10 is 1 times 10 and 2 times 5. So I could do, I'm going to say probably 9x and x, and then 10 and 1. So that way my inside and outside, when I multiply, I'm going to end up like this. And since I want a negative x, if I make the 10 negative, oh, but they both have to be the same. Hold on a second. I think I messed up on this one. Because that won't work. So then can we somehow do this? Okay, I did not want you to sit there and watch my whole thought process go, but essentially this does not work. We cannot factor this. So we're going to take this bit and we're going to use the quadratic formula, which is right here. And the reason why I stopped here to basically say like, oh, I know this for sure won't work at factoring wise is because this number is going to be a negative number. So my answer will be imaginary. And that's where we're at. So this is going to be 1 plus or minus square root. So this is 36. So 1 minus 360 over 18. So 1 plus or minus root 359, negative 359 over 18. And if I pull up a calculator, what's going to happen here? So if I go in and say, what's the square root of 359? Ugh. So that's actually going to be 1 plus or minus 18.9472. I don't know how many numbers after the decimal point you're going to need over 18. If I were this student, this teacher, I would probably accept this, or maybe not so much that actually. I would probably accept this, assuming I'm giving students a calculator. I want this actually pulled into two separate equations on the calculator. So, for example, 1 plus 18.9472 I over 18, and then the same thing, 1 minus 18 point blah, 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 right? Um, and then the other method that I would accept like this, or I would accept 1 plus or minus I root 359 over 18. I feel like though, at this point in the game, you're usually not allowed a calculator for an Algebra 2 exam. So I'm going to say this is probably more likely the accurate answer for this particular review worksheet. Okay, so now we've got for questions 5 through 9, this is my f of x, this is my g of x. So f and g just means that we're going to multiply. So I'm going to go 5 and x to the 1/2 times 2 and x to the 1/3. So I know I can multiply the 5 and the 2 to get 10. And then 1/2 times 1/3 is 1/6. So I'm going to have 1/6. And then that should be the final answer, right? So this f of g, or f times g of x, oh my goodness, I can't write, is this whole business here. In here, we're going to divide. So I'm going to have 5x to the 1/2 power over 2 times x to the 1/3 power. I know that I can take my exponents and subtract them. So when I have 1/2 minus 1/3, I need common denominators. So I'm going to multiply this by 3 over 3 and this by 2 over 2. So I'm going to end up with 3 over 6 minus 2 over 6, which is actually 5 over 2, and then x to the 1/6 power, because that's just 1 over 6. And then this would be, again, my final answer. In here, we're asked not just to find the sum of the two functions, but replace the x with 64. So when I take the sum, I'm just going to take 5x to the 1/2 plus 2x to the 1/3. And I can go in and say, okay, 5 square root of x plus 2 cube root of x. And that's going to be 5 root 64 plus 2 cube root 64. Square root 64 is 8. So 5 times 8 plus cube root of 64 is 4. So 2 times 4. So 40 plus 8 is 48. Ta-da! Final answer. Then it asks us to find the inverse of this function. So this is the function that we're looking at. Normally, I like to just replace the f of x with y because it makes my life easier when I explain things and when I do things. In order to find an inverse, I'm going to go ahead and flip-flop the x and y. So step 1 is flip-flop these guys. And then step 2 is we want y by itself. So my first thing that I can do to get y by itself is divide by 5. So I have x divided by 5 equals y to the 1/2 power. And again, in order to get rid of the exponent that's like this, I'm just going to square both sides. So I'm going to end up with x squared over 25 equals y. And then final answer, this is my, oh, well, I guess we could replace this y with f of x equals x squared over 25, and that should be totally fine. Then they're asking me what is the range of this inverse function, right? Or I guess maybe f of -1. Um, so my inverse function, when I look at this, originally, my function is a radical function. So when I look at a radical function, and here's my x and y on a graph, radical functions generally start off at 0, 0, and then kind of look like leaned down or a laying quadratic function, right? They kind of go up slowly, 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 and then they like whoosh, take off, right? In this particular case, I know that this is my original function. So when I find the inverse, and I know that I'm going to end up with this inverse right here, I can actually rewrite this as 1 over 25 x squared. So we know that x squared is kind of like happy face, sad face type of function. And then we also know 1/25 is going to be a vertical shrink. So essentially, my new function is going to look kind of like more like a bowl versus a champagne glass. Um, so this is more champagne glass because it's a little bit narrower. This is the bowl because it's less narrow. We also know that I can't possibly have both of these as my range because my original function just starts off with part of my quadratic function, part of my x squared graph. So in order for me to make sure that I get the right range of my inverse function is I have to determine what is really the look of the function originally, okay? In this particular case, I know that my domain was x is always greater than 0. So I know that the flip-flop version, which would be the range, would be y is always greater than or equal to 0. I also wanted you to see that, hey, it's just going to be this portion here, right? Because we're looking at a graph that is kind of a reflection of this y equals x line over this y equals x line. So if, let me see if I can make this a little bit better. So if this is my original function here, I know now that I need this function to go here because I have a line that goes like this y equals x line here. So this portion won't have anything to do with my range. Even though it doesn't change my answer, it still won't have anything to do with my range because the inverse function will not allow for that portion to be in the answer. Okay. Let's do the last one. It says, given the graph of this function, find the other function on the same graph. You can do this one of two ways. You can go in and say, hey, here's my y equals x graph. Or you can just flip-flop the point, flip-flop the x and y. So we'll have -2 instead of 4, -2. I'm going to plot -2, 4. And instead of -1, 2, I'm going to plot 2, -1. So my first point will be -2, which is right here, and then 4, which is probably somewhere up here. And the second point will be 2, -1, which is here. So if I were to draw this line here, you would see, let's make sure that I get it the right way. Kind of, sort of. Okay. The first thing you would see is at this point right here is where both graphs meet. Okay. So probably, I mean, this is a terrible example, but probably that's kind of where my reflection point goes. Okay. The other piece is the other method that you can use to solve this kind of equation or this kind of problem is you can say, hey, I'm going to find y equals mx plus b for my blue line, or sorry, for my black line. So I'm going to find the slope, and we're going to see that the slope is -2 minus 2 over 4 plus 1, so -4 over 5. And then we'll have to solve for the y-intercept. So 2 equals -4 over 5 times -1 plus b. So all I did was I just used this particular point, this -1, 2, and replaced it in my y and x so that I can solve for my y-intercept. This will just become positive, right? Because negative times negative is positive. And then I'm going to subtract 4/5 on both sides. Super gross numbers, not recommended at all. So my original equation is going to be y equals, -4 over 5 plus 2 and 1/5. Oh my gosh, so gross, x. And then in order to find the inverse, I would flip-flop both this x and y and make this x equals -4 over 5, y plus 2 and a fifth. And then I would get y on its own. So subtract 2.5, so y equal x minus 2 and 1/5 equals -4 over 5y, and then multiply by -5 over 4. Multiply this whole side by -5 over 4. Yikes. Okay. So -5 over 4x. This is what, -11. So I have -5 over 4 times -11 over 5. So the 5s will cancel, the negatives will cancel, and I'll end up with 11 over 4, which is 2 and 3/4. So plus 2 and 3 over 4 equals my y. And then go in and graph that. But that is a really gross thing to graph. I would just go in and change the x and y to get my reflection over the xy axis. This is probably a more challenging problem. I don't anticipate you'll have very many problems like this on an exam, assuming that this is where you go to do the math. I think this is probably an easier portion, an easier method to use to solve this particular problem. Alrighty, and I will see you in another video. Bye.